Hello, this is a little video to help you prepare your report for the titration online assignment. So I have the report preparation page here and I just want to go over it with you. So at the beginning, it says, let's take a look at the data that you're supposed to use and plot. And I'm looking over here, the strong acid, strong base report first. This guy right here. It says, using the provided HCl data, make a plot of pH versus the volume of NaOH titrated pertaining to the HCl neutralization with NaOH. Then print out the appropriately titled, including axes, blah, blah, blah. So what is that going to look like? So I'll just put it over here. This is going to be graph 1. Graph 1. So we're going to have pH versus volume of NaOH. And that's in units of molarity. So that looks like it's all appropriately labeled. You can title it at the top, whatever title you want. HCl titrated with NaOH or whatever. And so that plot, once you get it up there, it's going to look something like this, okay, where it goes through this inflection region and then goes something like that. Actually, it's going to look something like that. So you're going to print that out. That's what it says. And then it says, on graph 1, use the midpoint of the inflection region. Now the inflection region where that's where there's a steep rise in the pH. So this is the inflection region right there. So it says take the midpoint in the inflection region as the equivalence point, and you're going to want to put the numerical value of the volume. So right in the middle of that, I eyeball it somewhere around there. I get a ruler on my piece of paper, drop a vertical, and then I identify what volume that is. That's the volume at equivalence point. And then I put the value in, whatever. And then it says mark the spot and write out the pH value at the equivalence point. So I have to get my ruler out again, do a horizontal, and then put right here somewhere pH at equivalence point equals whatever value that is. And moving right along, number 3, it says note phenolphthalein changes from colorless to pink. 8 to 9.8 on the plot. Note the pH where it's active and bracket to mark the titration curve in that region. So in your plot, you're going to have values here and here, right? So at 8 to 9.8, you're going to go over to your plot and do a bracket and write something like, phenolphthalein active. And so far so good, and no problems. That brings us to 4. Give the balanced chemical equation for the reaction of HCl with NaOH. Use this along with the volume of NaOH required to reach the equivalence point to calculate the concentration of the original 15 milliliter sample of HCl. So what happened in this experiment was you had 15 milliliters of HCl in the beaker that was titrated with NaOH. And if they're the same concentration, then you know this volume over here at equivalence point should be around 15 milliliters. But anyway, they want the balanced chemical equation, HCl plus NaOH neutralization to give me H2O and salt, NaCl. So that's aqueous, and that's liquid. This is aqueous and aqueous. And then they want me to do a calculation for the concentration of HCl based off of the fact that the NaOH was 0.1 molar. It doesn't say that here in the question, but it does in the part of the experimental, which you should read over so you kind of have a good idea of what is going on here in this mock experiment. All right, so I have the volume of NaOH at equivalence point. If I multiply that by the molarity of NaOH, which you're going to look back into the lab and see that it's 0.1 molar, then that's going to give you the moles of NaOH. I know that for every 1 mole of NaOH, there was 1 mole of HCl, because it's a 1-to-1 reaction. So all I need to do is divide that by 0.015 for that 15 milliliters of HCl sample that was titrated, and so that should give me the molarity of HCl. And then we're done graph 1, and you just upload that sheet into Canvas for your report. All right, graph 2 and 3. In this graph, you're going to make the same plot. It's the phosphoric acid with NaOH. So you're going to need to, do the title and the axes with the appropriate units, just like we did before. But I'm just going to write here what it looks like. It's going to look something like this, right? And so I'm going to print that out 2 times. And then on one of those, I'm going to do this. On the other plot, I'm going to do the rest. So I could recreate this plot. And make sure I have my titles and axis and stuff like that. Now let's go back to graph 2. So this will be graph 2, and this will be graph 3. It says use the midpoint of the inflection region, the 2 vertical parts, to mark and write out the values for both the volumes for the first and second equivalence point. So it's essentially the same thing that I did up there. There's the midpoint of the first inflection region, midpoint second. I drop down a vertical using a ruler, and I do first equivalence point, volume first, and whatever it is, whatever your axes say, second equivalence point, you're going to put a number in there. Then it says, give the 2 balanced chemical equations for H3PO4 and NaOH that correspond to the reactions that took place before the first equivalence point, as well as the reaction that takes place between the first and the second. Use those balance equations along with the values at of the volume of NaOH to calculate the concentration of the 15 milliliter sample of H3PO4 that was titrated. So it's kind of the same as before, but we have to be careful of those reactions. So I want to go over that with you. So in this first part, before the first equivalence point, what is the reaction that's taking place? So for that one, I know that there's phosphoric acid in there. And I know I'm adding NaOH. And I know that I'm getting H2PO4 minus plus H2O plus Na plus. Okay. That would be for the first equivalence point. Now, to the second equivalence point, the reaction to get me from that second to the third is going to look like this. H3PO4 plus 2. NaOH goes to HPO4 2 minus plus 2. H2O plus Na plus. So there I have my two reactions taking place to get me to the first and then the second equivalence point. Now, how can I calculate the concentration of the phosphoric acid using both of these values, the volume for the first equivalence point and the volume of the second? Well, I'm going to have to use these stoichiometric ratios just like I did up here for HCl. It was a 1-to-1 for HCl. For the first equivalence point, it's going to be 1-to-1 as well. But for the second equivalence point, it's a 1-to-2 ratio. But it's essentially the same. I'm going to take those volumes of the NaOH at equivalence point 1 times the molarity of NaOH. That's going to give me the moles of NaOH. It's a 1-to-1 ratio to H3PO4. That gives me moles of H3PO4, and I just divide that by 0.015 liters. And that's going to be fine for that. Now, the second equivalence point, I'm going to use that volume V equivalence point 2. And that's going to be approximately double that first one. So you're going to get double the moles. But check this out. It's going to be 1 mole of H3PO4 for 2 moles of NaOH, because now I have to use these stoichiometric coefficients. And so even though it's double the volume here, it gets half because of the ratio. And when I divide that by the volume that was titrated, I'm going to get approximately the same value for the concentration of the, for the concentration of H3PO4. So it should be around the same. And they want you to calculate the percent difference between those two. And you're going to work that all out. You could write that right on the piece of paper that you printed out with the graph on it, those calculations, no biggie. And do the same thing here. Print out graph 3 like this. Make sure you have it. You can even write in the titles if you want. No big deal with that. Volume of NaOH and stuff. Just I find it's easier just to go ahead and write it all out, and then you can take a picture and upload that in the Canvas or scan it or whatever. All right, so what do we have to do on graph 3? Let's see, it says indicate on the y-axis, that's the pH axis, the locations and numerical values of the pKa's. All right. The pKa's, if you should read that lab because it talks about, you have the equivalence points right there. Now the pKa is found equal to this special point right in between the initial volume, which is 0, and as you get to the equivalent point. So that's the half titration point. It turns out that at the half titration point, the pH here equals the pKa for the first equivalence point. And then right in between the two equivalence points, again, we have another half titration point, and the pH at that half titration point equals pKa2. So you're going to plot that out and mark it up, understand why that's true from reading the lab. And then it says for number 2, roughly bracket the NaOH volumes corresponding to both buffer regions. So if you look in the lab again, they talk about the buffer regions. And the buffer regions are usually taken to be plus and minus 1 pH unit around that half titration point, because that's where you got a weak acid in the presence of its conjugate base. So that's buffer region 1, and buffer region 2 is going to be somewhere up here. Now you should read through that background material and understand why that those are buffer regions, what's in them. And for example, the first part, you're going to have some leftover H3PO4 because not all of it has been neutralized with the NOH in that region. But also you're going to have in that region the conjugate base, H2PO4 minus. So that's the one buffer system in the first case. In the second case, you're going to have this guy and its conjugate base, because this is really amphoteric. It can act as an acid or a base. And in this context here, it's the conjugate base of this acid, but it also has a conjugate base itself, and that could be acidic because these protons here can still be lost. So it can act as an acid or a base. When something does that, we call that amphoteric. So you're going to figure out what's in this region as far as the buffer system. And that'll address this question. And you want to show the acid in equilibrium with its conjugate base. Okay. All right. The next thing, it says use phenolphthalein as an indicator. We know from the previous graph 1 that phenolphthalein is active and a pH of 8 to 9.8. So you're going to put that on your plot and then go over and bracket out that area, wherever that is on your plot. And that's all for number 3. The last thing, number 4, asks you to use this equation for estimating the first equivalence point. What it says is just add up pKa 1 and 2 and then divide it by 2, or take the average of pKa 1 and 2. And if we look over here, you're going to have pKa 1 and 2, and you'll know what number it is. So you should say whatever it is on the plot equals whatever. And if I take the average of those two, you can see that's going to put me pretty close to that first equivalence point when I take the average right there. So do that, calculate it, and then compare it to that first equivalence point by I don't know, say this one's greater than that one, or maybe do a percent difference between the two and report that as your comparison. So I hope that was helpful. If you have any questions, please don't hesitate to post them, and we'll get to them as soon as possible.